The two gray rectangles in the diagram are congruent. Both have an area of 3 square centimeters. What's the area of the large rectangle ABCD? To make it easier to solve the problem, we might label some of the intersection points in the diagram with letters. This also helps me explain the solution more clearly. When approaching the problem, the first step is to carefully read the given information and highlight the key conditions. In this case, we are told that two gray rectangles are congruent and that their area is 3 square centimeters. After reading the question and identifying the key points, we move on to the observation. To find the area of the rectangle ABCD, we can either get the length and width of ABCD or just add all the subareas together to get their total area. Looking at this diagram, the first method doesn't seem promising due to the limited information. So let's try the second approach. Can we express the area of rectangle ABCD as the sum of a rectangle AEFD, triangle FOG, and triangle FGC, and the trapezoid EOCB? We already know the areas of AEFD is 3 square centimeters and triangle FGC is actually the half of the gray area. It's 3 and 1.5 square centimeters respectively. However, the areas of FOG and trapezoid EOCB are unknown. Now, if we look at the diagram, we can find if we can prove that the triangle FOG is congruent to the triangle of AOE, then the combined of the unknown area would just equal to the area of triangle ABC. Actually, the area of the triangle ABC is exactly half the area of the rectangle ABCD, which is we are trying to find. So, let's now prove whether these two small triangles are congruent. First, we know that vertically opposite angles are equal, and both triangles have a right angle. Also, since the two great rectangles are congruent, AE is equal to FG. These three factors together are enough to prove that the two triangles are congruent. Now, let's go back to the earlier formula. So the area of ABCD of this or the sum of the subareas, and we already know the area of the AEFD is 3 and the triangle FGC is 1.5. And since the FOG of the small triangle is equivalent to the or congruent to the triangle of AOE, so we can write them together. It's the triangle of ABC. And triangle ABC is actually half of the area of the rectangle ABCD. So then we know the half of the rectangle ABCD's area is 4.5, which means the full area is 9. Therefore, the answer is B.